Okay, so factoring this guy with an exact method. First, we don't like to have a negative number to start off, because then you've got to be thinking about a negative times a positive and all this negative stuff that gets you messed up. So what you need to do is factor out that -1, and what that does is it changes all the signs on the inside. And now we're dealing with something that has a positive term to start with. Because if you multiply this -1 back into everything, it turns into what you started with. So this is a little more, factoring this guy is a little more complicated than maybe what you started with when you had just x squared plus 2x plus 1, because now we have a number in front of here. And when you're trying to picture your two parentheses, it was easier in this type of problem, because the first number, x times x, gives you x squared. There's no ambiguity there. When you're factoring, you're trying to think of two parentheses that multiply to be what you started with. So what do you put to start off these parentheses? Do you do 5y and 3y, because those multiply to make 15y? Or should you do 15y and 1y, because those also multiply to be 15y? So since you have options, we need a longer method than what we did over in this section. Okay, so a wise old teacher once said this is the magic number method. This method will always get you the right answer. That way you don't have to do any guessing and checking. Take the first number, the a coefficient, and multiply it to the last number, the c. Do 15 times -18. Gives us -270. Okay, so yeah, this is kind of a big number, but what you need to do is think about all the different factors, two numbers that multiply to be -270. And the reason why will be clear in just a bit. So we know 5 would fit into 270. That's 54 times that fits in. 270 is even, so how many times does 2 fit into 270? Man, I'm a math teacher. I should probably know this, but needed a calculator. 135. You can keep going through the list, try to think of all the different pairs that multiply to be 270, but the ultimate goal is to be looking through these pairs and finding a pair of numbers, find a pair of numbers that add up to be this middle term. For example, 5 and 54, I can guarantee you that's not going to work, because if you make this one be negative, -5 plus 54 makes positive 49, and that's not 17. Or if you made this negative, it's still not going to work. These two are still too far apart. These two are even further far apart. Those aren't going to work, so let's keep looking for pairs of numbers that multiply to be 270. So how about... move that up there. So how about 10 and 27? Looking at this pair, we're still, the goal of finding all these pairs is to find two numbers that multiply to be -270. So we have an option. And we need a negative times a positive to make a -270. So which one should be negative so that they add up to be -17? Let's make this guy be negative. Because 10 plus -27 makes -17. This is the pair that we need here. So just a quick recap. We used the magic number. We multiplied the first number times the last number to make our magic number. And then we found a magic pair for that number. That's 10 and -27. Because this is the magic pair, because these two numbers add up to be our middle term. So what we're going to do is we're going to rewrite this whole expression, what we have right now. We're not fundamentally changing it. We're just changing how it looks. And the only thing that's actually going to change is this right here. We're going to replace this with our magic pair. Okay, so check out what I wrote. Isn't this the same thing as this? 10 subtract 27, that makes -17. So I haven't really changed the problem yet. I just changed how it looked by replacing the middle term with my magic pair. So I got 10y minus 27y in here. And the reason why we've expanded it, made it look a little longer, because now if you just factor this stuff by grouping, you'll have two parentheses that multiply to be what you started with. So a recap, if you don't quite remember factoring by grouping, that's where you put parentheses around the first two terms, parentheses around the last two terms, and factor out what's in common. And in this first set of parentheses, we still have black parentheses around everything. This is all in a bunch. And in the first green parentheses, we have 15y squared and 10y. Those both have a y, and those both have a 5. So I'm going to divide a 5y out of both of those. And what's left over is a 3 and a y in that first term, and a 2 in the second one because we divided out the y. So now let's do the same thing for the next green parentheses. We have negative 27y subtract 18, and we don't like negatives, so since both those are negatives, let's try to factor out a negative term from those. Both those are divisible by 9, so let's take out a negative 9, and write what's left over. Divide that by negative 9, divide that by negative 9, what you have left is a 3y from that blue one, and you have a positive 2. Okay, and so that's factoring by grouping. And what you should see when you factor by grouping is you should see, oops, let's get rid of this up there, that over there. That looks a little less cluttered. When you factor by grouping, you should see two parentheses that are the same if you've done it correctly. And we've got it right there, a 3y plus 2 and a 3y plus 2. So now we're ready for our final answer here. The negative 1's still hanging out on the outside. We have two parentheses of the same, so we're going to factor that out of both of those terms. And then we have stuff left over from the outside. That's a 5y minus 9. And this is it. We factored the original expression. So go back to the problem that we started with. If you multiply this parentheses out, it should turn into what we had for it should turn into negative 15y squared plus 17y plus 18. Multiply all this stuff out like we did in previous work in whatever course we're in, should turn to what we started with.